Hello and welcome to another exciting Breakfast with Unity. I'm your host, Max Moreau, and today we're going to be doing some non-rigid body conveyor belts. So this is kind of more intended, I'm going to kind of set this up in a pseudo 2D environment for our test, though it can work in either. This is kind of more for games that don't have a physics-based component as much. Maybe you have a platformer that you're just doing kind of old school style where pixel jumps are exactly the same each time. And this will work for any type of object. It doesn't have to have a rigid body on it. It can actually have a rigid body on it and still work with this conveyor belt. But it might not work exactly the same physically as you'd expect for a real conveyor belt. We may do a physics-based conveyor belt later, where we actually have a physical drive using some sort of what is it called? Friction-based system. Or maybe still some sort of hack, just because the friction-based systems are really difficult to do in physical systems in games right now. Anyway, let's actually just get to this thing. So I'm going to go ahead and create a new scene, and let's just go ahead and say this scene, get this part over with. Non-rigid body conveyor belt. I'm probably spelling things wrong, but I don't care. Save. I actually care deeply. So what we're going to do is we're going to create I'm just going to create this big old 3D cube thing to represent a conveyor belt, and we're just going to stretch it out along the x-axis. And I'm just going to switch it to 2D. We're just going to pretend this is a 2D game for a moment. And what we're going to do is we're going to create a script right off the bat. Let's just do it. So create C# script. It's actually very simple. We're going to call this, what should I actually call the script? Move target, move client, move. So normally I try to name things in a generic way that's useful in a generic way. So you could use them for things that aren't strictly a conveyor belt or strictly one thing or another. In this case, we're going to be applying a movement vector to an object that comes into a trigger. Usually I name things for what's happening on the object that has the script, but in this case we're going to be doing something with the object that hits the trigger. So I'm going to call this move triggered object forward is what I'm going to say. I'm not sure if this makes perfect sense for the name, but I think it'll work for our purposes right now. So we'll open up MonoDevelop, and we'll go to the actual script, and we will create a couple variables: public, float, speed, maybe only one variable. And what this is going to do is we're going to use void on trigger stay is what we want. And what we're going to do is on trigger stay. This is for whenever you're inside of a trigger. It gets called every time that you're inside that trigger. And we're going to actually use the collider here that we can get. So you can specify a collider, and you will get the collider of the object that triggered this. This is technically a little bit slower. We generally don't use this if we can avoid it, and the way we usually avoid it is a lot of people use this for checking to see what you've hit or what tag you've hit, which is slower than just making the physics system not have things hit or have things hit and then just calling it by itself. But in this case, it's perfectly valid, because what we need is the information about what we've hit, because we're going to do something with it. So we're going to take this call.transform, and it's going to be really simple. We're just going to do plus equals transform dot forward times speed times time dot delta time. What this means is, however we've organized our conveyor belt, whatever direction is facing, whatever direction the actual device or object that we're putting this on is facing, is the direction it will apply force to. So, well, not apply force. It'll apply movement too, because we're not using forces. So, plus equals cannot be used for these things. What do I do? Oh yeah, transform. We want transform dot position. I was just trying to change the transform, which doesn't make any sense. So what this actually, so this is our current transform dot forward. This for the object that has the script, and so this just means go that direction at your speed and multiply by time dot delta time. So it's actually per second rather than per frame. So let's save that. Should be working. So what I'm going to do is I'm going to create a, we're going to call this conveyor belt. I'm just going to call it conveyor belt. But what's actually going to have the script is going to be a child. We're going to create a child called conveyor conveyor belt area is what I'm going to call it. And this is what's going to have the script and actually do the work. So we're going to add a physics box collider here. And we're going to set it as a trigger. And I'm just going to move it up in the Y here. And it should just work. In this case, we might want to actually... No, this is probably appropriate for this. I scaled it just directly here. Depending on how you set things up or your art, you may have like multiple cases or different things that have the rigid body here. Keep in mind that if you have multiple ones of these, once we set them up, and a player is touching both of them, they will both accelerate him. So if you have to break it up into tiles or something, make sure that the tiles are bigger than the player. That doesn't solve everything. There might be a couple other edge cases there. I'm not going to worry about it too much right now. We're just going to deal with one big conveyor belt here. So we're going to now look at our object here. I'm going to look at it in 3D just so that we can see the little doohickey. And yeah, I'm actually going to change the scaling areas again. No, I'm not. Yes, I am. So we're going to create an empty game object. We're going to... Is this at the same position? It is. We're going to put this inside of it, and then we're going to make these siblings rather than parent relationship. This will make it so that we have a little bit more fine-tuned capability on this. We can rotate them differently, and their scales won't affect each other. So we need to rotate this thing so that it will face the direction. We're going to have the conveyor belt go right. So we're going to rotate this 90 degrees. So now the blue arrow, which represents the Z, which is the transform.forward that we're using, that's the direction it's going to go in. Obviously, we need to change the way this is scaled, so I'm just going to copy the 14.22 here, and we're going to put it into the Y. No, not into the Y. Into the Z. There we go. So now this should represent movement to the right. So the way we can test this is we can put any object in there, and it should move, as long as the object has a collider of some kind. So... let's do a cube. We might have to put a kinematic rigid body on here, just maybe. Let's see what actually happens, though. So, conveyor belt area, we're now going to put the move turned object forward on here. Oh, didn't have a good default. I'm going to set it to 1 here, but let's actually give it a good default. Equals 1.0 F. So, the next time when we just drag the script in, if we hit play, it'll do something. So, if we hit play, hopefully, we will get movement on our cube. Or we will crash. No, we didn't crash. But we didn't get movement on the cube. So let's look at our cube real quick. So this has a box slider. So I have a theory that if we manually jiggle the cube... No, maybe not. Conveyor belt area. Okay. Here, let's see if I pull this out and put it in. Well, that didn't work. That's okay, though. So... move triggered object forward, speed 1. Alright, so I'm going to give this thing a rigid body just for right now. I know I said non-rigid body, but like, I really meant kinematic is what I should have said, but we'll see how this actually goes. So if this works, does this actually work? Okay, so this does work. So the problem is at least one object has to have a rigid body on it for the collision system to work, even if you're just using triggers. So I lied, it's a kinematic rigid body, not non-rigid body, though it's kind of the same thing in this case. We're using the rigid body just to drive the collision system. And I don't know why I said it that way. I actually was originally going to type it as as I was going to call it kinematic conveyor belt, but then I didn't. But that's okay. We can always change the name later. So this works now. Now we can do this with any object that has a collider and a rigid body, or we could put the rigid body on the... We could do the same thing on here. We could just do component, physics, rigid body. Though, honestly, if you're going to be moving this character around anyway, you're going to need a kinematic rigid body for his colliders to work anyway. And this object is probably not going to be moving around the scene. If it is, it should have a kinematic rigid body as well. But we're not using the rigid body for the actual physics system. We're not using any of the physical interactions. It'll still work with physics too. So if we take the cube and put a change it to use gravity and turn kinematic off, it should fall onto this and start moving to the right. But as I said, the physical system is going to be a little bit different here. In this case, we're also generating some drag. We're not actually using the physics force stuff, so you might have situations where you have rogue forces on this object that maintain because of the way that we're doing it. So keep all these little things in mind. What else can we do with this? So this works in 3D or 2D. We just set it up in kind of a 2D way. I'm going to actually put a light in the scene, and let's just create a non-rigid body gravity system. So let's just do I'm going to call it kinematic gravity. I'm just going to do this. So we're just going to make this to show. This is also to show a little bit how gravity is actually calculated. We're doing just the gravity component. We're not doing any other forces or anything. But this is a way that you can kind of track this stuff internally yourself. So so you could have a linear. We could do this as linear gravity, or you could do it as exponential gravity. I'm going to do kinematic linear gravity. We're going to do it linearly. We're going to do it the easy way first. Save. Rename this thing. And we're going to say, oops, we're going to open it again because we changed the name. And so we could use the existing gravity system in the physics system to do this. And I think I'm actually going to do that, though I might have an option to not do that. Let's just do it. So gravity is already defined here as a vector, so this is kind of useful. So let's just use the built-in gravity for this for right now. Now we're going to do this in a linear fashion, so it's not going to react. It's not going to accelerate as it goes down in this case. So all we're going to do in update is transform dot position plus equals physics dot gravity, which this represents the vector. This is the vector 3 that was just this defined up in here. And because it's already set up as negative, we just do plus equals. This should work. So let's. Oh yeah, and we also want time dot delta time. Otherwise, we'll move very very fast. So if we do this and we attach this to an object that we want to have gravity on, it should operate as if there's gravity. So whoops. Although it's going to operate double. And actually, this is not a really good example because it's not going to collide nicely either, is it? So we're going to turn off gravity. We're going to turn on kinematic, and it's going to go right through that thing, isn't it? Yep. So the reason this is happening is because we're just doing a move command, and because this is a kinematic object, it's going to hit these colliders, but not actually be stopped by the colliders. Shoot. Yeah. There's a lot of things you have to worry about when you're not using a physics system. So, do we want to fix that real quick? Yeah, let's do a quick. We'll do a quick collision check here. So what we're going to do is you're going to use a raycast collision check. So if raycast. Are we going to need raycast hit? No, we're not. If physics dot raycast dot, and so what we want to raycast is we want to raycast from transform dot position, no, lowercase transform dot position. We're going to raycast out. The one we want is we just need origin, direction, and distance. So transform dot sorry. So the second one we're going to use physics.gravity. Physics.gravity. So this is the direction we're raycasting in because we're checking to see if we're going downwards or whatever direction gravity is set to, right? So so we're going to raycast down. And then the distance we're going to use is whatever... I'm going to go ahead and do this phrase right here. And actually, let's pre-calculate so we don't have to do that calculation twice. So we're going to call this float gravity amount equals, I'm going to call it gravity distance. Oh, wait. So, sorry, this isn't gravity distance. What is this? This is, I'm going to call it gravity time. And in this case, we actually want gravity time dot magnitude. Oh, wait, this isn't a float. This is a vector 3. So gravity time dot magnitude, and this one we're going to use gravity time here as well to replace that term. Whoa, what did that do? That was weird. Oh, I see. It just tabbed it over. Okay. I thought it had somehow gotten rid of some of my typing on the left. All right, so that's just because I had this open. And so we actually want it if not raycast. So basically, if we don't hit something with this raycast, then we do this gravity thing. Else, if we do hit something with this raycast, well, let's just see if this works first. Let's just see what this does. Save. So we're now going to hit play. There we go. It fell down until the raycast here. So now we did have a problem. It actually is raycasting against the trigger, I think, because it seems like it's happening earlier than it should. But it is doing something. So the reason this is happening, and we're not going to change this globally because it'll break too much other things, because I think I'm going to make this assumption a lot. So in physics, there is an option here. You can turn off raycast hits triggers. This will probably make it go more onto the actual bar. Actually goes into the center of the bar. So we have another problem as well. But that would solve that problem. So we may have to have a layer mask here. So let's go ahead and do it. Public float, public layer mask. Kind of doing different things than I thought I was going to be doing on this episode, but that's okay. Public layer mask, equals -1. So this will just be everything by default, and then we can change it. And we need to do this a little bit differently. So we need to have it be gravity time dot magnitude plus. So actually, let's not do plus. Let's not fix it this way. Let's fix it in the editor. So what we're going to do is we're going to call this character, and we're going to create an empty child inside this character, and we're actually going to reverse this. And what we want to do is we don't want to reverse it completely. So we want the cube and the box collider and stuff in here, but we actually want the gravity to be, oh wait, what do we want where? Why was I doing this? I was doing this so that we could offset the character, which means, so I want the center of this object. Okay, so this will have the gravity on it, and everything else will be on here. So copy component, remove component. Actually, that's not true. The rigid body has to be up here too. So paste component as new. Let's grab the rigid body, copy component, remove component, paste component as new. I don't think we have to move the collider, because the collider should actually move its collision information up into the rigid body, but we'll find out. And the reason we can do this, we're doing this, is so that we can do an offset of 0.5 in the Y. So now this will represent the bottom of the cube. So I'm going to go again to project settings. Actually, I'm not going to. So physics, we still have it hitting triggers, good. And let's actually use our newfound, our new little option here. And oh, we didn't save it. We also aren't using it, so that might help. So we need to actually put this layer mask in here somewhere. So distance layer mask, perfect. Save. And now this should show up with a pull down. There we go, layer mask. And we're going to make it so that this will ignore, what are we going to call these? I'm going to call this, actually, we didn't even have to do the layer mask. I'm going to leave it there though, because it's useful. We could have actually put this on the ignore raycast layer, and that would probably solve it. So So let's actually try that one first. We're just still going to collide with everything and hit play here and see if it goes down where we want it. Nope, didn't fix it. Conveyor belt area, ignore raycast, failed us completely. So that's fine. So what we're going to do is, I don't know what that layer actually does, considering that's a built-in layer, and I thought it actually did ignore the the raycast. Well, let's just make it so that we explicitly ignore the raycast layer in this. Silly, but we're doing it. Oh, and I just realized this is not going to work. Wait, yeah, it is. So what are we doing? We're just going to say, don't do raycast. There we go. Yay! It fell onto it, and it's moving. Hooray. So you'll see, finally, there's one last little bug. This thing doesn't quite land onto the platform. Basically, once it gets to that range, it stops. So we do need one last thing to fix the edge cases. I'm actually going to have the positive case up here. We're going to do else, and then do the negative case down here now that we're doing an else statement. I usually like to do it that way. You can do it the other way. It doesn't matter. It's just a style thing. I like to start with what, if it happens, if it doesn't happen, else if it doesn't happen, versus if it didn't happen, else it did happen. Sometimes it makes sense to do it the other way, though. So, what are we doing? So, all we're going to do is, if we get this raycast, we're going to move the object to the raycast position. Now, the only trouble with this is we need one more variable now. We're going to need our raycast hit. We're going to have to actually use this. So hit, and we're going to throw that into the equation here somewhere. So we've got distance, layer mask, hit info, distance, layer mask. So we have to actually sneak this in. Hit info right here. It would be here, not that. We want hit. And specifically, we want out hit. Save. Let's see if that actually works. And so what we're going to use now is transform, or sorry. So we're in here, and we'll then set transform.position equals hit.point. And let's put this into late update. So this happens after all the other stuff has been calculated. So let's see how this goes. Hit play. Oh, did something wrong. What happened? Oh, it's... So I think somehow it's raycasting into it and getting a hit dot point because we're interpenetrating afterwards. So this is not going to work exactly right. How can I fix that? So instead of doing it every raycast, going to the hit dot point, maybe I should do closest point on bounds for the collider. Here, let's try that. Wait. Hit.collider.closest point on bounds, transform.position. This will only work with cubes, though, so I'm not really keen on this. But let's try it. Transform.position equals hit.collider.closest point on bounds, transform.position, hit play. Nope, didn't even fix it. Here, what we'll do is we'll do transfer to position. You know, we're 25 minutes in. I'm just going to put it here. Handle offset from surface problem here. All right, well, we'll cover this sometime later. Sorry that this is kind of anticlimactic, but I actually covered more than I thought I was going to be covering today anyway, so I guess that's good. Just still wasn't 100% complete, so my apologies about that. Anyway, thank you very much for joining me this morning. Hopefully you had a good breakfast or tea or whatever it is that you are having with your Unity in the morning or afternoon or night, whenever you might be watching live, or watching at your leisure later in the future. So, thank you very much for joining us. If you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Dragfire. Please support us on Patreon, patreon.com/cookingwithunity. We need your support. Thank you very much. If you support us, we give you access to the Cooking with Unity super repo, which is on GitHub, and so it has more cool stuff in it. And I keep adding little things here and there to it, so just keep checking it back there, and there's cool stuff. So, thank you very much, and you guys have a great one, and I will catch you tomorrow with another Breakfast with Unity at 9 a.m. PDT. Thank you, or I guess PST now, but I think that both of them will get you here. Thank you very much, and you guys have a great one.